Good afternoon, ladies and gentlemen. I'm Mr. Khati, and with me, I have Mr. Motlengwa, and we'll be dealing with proportionality today. We will finish off similarity on the 6th of May due to time. Right, Mr. Motlengwa will come in when we have to deal with area questions. Right, let's dive right into it. Theorem 1. Oh, before I continue, please mute your mics. Everyone who's part of this meeting must mute their mic. Thank you. Theorem 1 says a line drawn parallel to one side of a triangle divides the other two sides proportionally. That is, we are given triangle ABC with line PQ parallel to BC. Take note that AP over PB is equals to AQ over QC, which is not the only one that we can write. We can also have AB over PB. Take note, I took the whole side of AB and I took that portion of PB. Is equals to, now, the corresponding side on the other side of AB. AB will go with AC. Remember, I took the whole of AB, so on that side, I must take the whole of AC. So that is AC divided by, now I took PB, PB goes with QC. Take note, PB goes with QC. So more will have to divide by QC. For the writing. Okay, seems like we have a technical problem. All right. As I was saying, we can take, it's not only this ratio that we can take, AP over PB is equals to AQ over QC. We can have AB over PB. Now take note that AB on that other side goes with AC. Remember, we took the whole side of AB. So on the other side, I have to take the whole side of QC, of AC, divided by, I took the small portion of PB. So on that side, I have to take that small portion of QC. Right. Another one that we can have AB, still AB, over AP. Take note, this time around, I took the whole side of AB over that region of AP. So AB on the other side goes with AC, divided by AP, this time around will go with AQ. So whenever we are using this theorem or applying it, our reason is always line parallel to side of a triangle. Right. In the next slide, example 1, we need to calculate the value of x. Take note, in order to apply this theorem, we must have a line drawn parallel to a side of a triangle. And this question, PQ is parallel to BC, so I can apply the proportionality theorem. Now, how can we solve for X? Take note that we have AQ. X is AQ divided by what other portion do we know on that side of AC? It is the portion of QC, right? AQ goes with AP on the other side. Remember, I took AQ and I took QC. So AQ goes with AP on that side. So I'll start with AP. In that denominator. Remember, every time you apply this theorem, your reason will be line parallel to side of a triangle. Now all we have to do is to substitute. What is AQ? AQ is given as X that we have to calculate. Divided by QC. QC is given as 4 meters. I will leave the units out. Right. Now, the converse of this theorem requires us to prove that PQ will be parallel to BC. If I take AP and I divide it with BP, this gives me MK over NK, which is M over N, because the K's will cancel out. Now, AP goes with what portion on the other side? It goes with AQ. So I will start with AQ. And then BP goes with which portion on that other side? It goes with QC. Now, what is the value of AQ? It's given as MT. Divided by the value of QC, it's given as NT. Take note, the T's cancel out. I'm left with M over N. Now I have proved that the ratio of AP over BP is equal to the ratio of AQ over QC. This simply means that we can conclude that PQ is indeed parallel to BC. And the reason here will be line divides two sides of triangle proportionally. Right. Example 4, prove that PQ is parallel to RS. If we take AP and divide it with PR, what is the value of AP? It's 14. The value of PR is 8. If we plug this in the calculator, it gives us a ratio of 7 over 4. So the ratio AP to PR is 7 over 4. Then AP goes with AQ on that other side, so I need to start with AQ. And then PR goes with QS on that other side, so I'll divide by QS. AQ is given as 21 centimeters, and QS is given as 12 centimeters. If we plug that in the calculator, it gives us a simplified ratio of 7 over 4. Then we need to check. AP over PR is 7 over 4, and AQ over QS is 7 over 4. So this line PQ divides the two sides of a triangle in proportion. Now we can firmly conclude that PQ is indeed parallel to RS. And what is our reason for that statement? I mean, for that conclusion? Line divides.
I'm confused.
Two sides of a triangle proportional. I hope we are still together. Now, this is just an introduction of proportionality. For us to master the questions that we are going to do, in proportionality, we need to understand the simple concept of multiple ratios on a line. And I'll try to be a bit slow here so that learners can grasp this concept. In the following sketch, the ratio, remember this is a ratio, AB to BC is 3:2, and BC to CD is 6:5. Let us represent this ratio on this line. It says from A to B, B to C. The ratio is 3:2. I cannot just write 3 and 2 because if I write 3 and 2, that represents the actual length. Because it's given to me as a ratio, I need to attach a letter to it. So I'll name this 3K and I'll name this one 2K. Please, do not just write the ratio as it is. It's a ratio, attach any letter to it, any letter that is not part of the diagram. So I chose K. AB to BC, its ratio is 3:2. So I wrote the portion of AB as 3K and the portion of BC as 2K. Then we are given the ratio BC to CD. The ratio is 6:5. Right. So I cannot just write 6 and 5. I need to attach a letter to it. Yet again, I cannot use the same letter that I used for AB and BC. So I'll choose a different letter. I will have 6P, 5P. Now you will have to look for a region that contains both letters. Let's start. AB, I only see 3K. BC, on top I see, the bottom I see 6P. There is my relationship. So I know 2K will be equal to 6P. I divide by 2 and I divide by 2. I have K is equals to 3P. That is the relationship between K and P. If I was to go back, we are given the ratio AB to BC is 3:2. When we represent the ratio on your sketch, do not just transfer the numbers 3:2. Attach letters to it. So for AB, I'll have 3K. BC, I'll have 2K. For BC, again, BC to CD, its ratio is given as 6:5. So now I need to attach a different letter. For BC, I have 6P, and CD, I'll have it as 5P. Then you look for a region that has both letters. AB only has K, CD only has P, but BC has both of them, which is 2K, 6P. And that is where we establish the relationship. So 2K is equals to 6P. Divide by 2 on both sides, I have K is equals to 3P. Now that I have a relationship, we can easily answer that question. The question says we must find the ratio AB to CD. Remember, a ratio can also be written as AB over CD. My mistake. AB over CD. Right. Now let's look on the sketch. What do we have for AB? For AB, I have 3K. And what do we have for CD? For CD, I have 5P. Remember, we have a relationship between K and P. It says K is equals to 3 times P. So in the ratio AB over CD, wherever I see K, I will now substitute with 3P. This will give me 3. In place of K, I will substitute with 3P all over 5P. Now multiplying, this gives me 9P over 5P. The P's will cancel out. Therefore, the ratio of AB to CD will be given as 9/5. We have another example here. In the following sketch, PQ to QS is 2:3. And QR to RS is 5:3. Let us represent those ratios. Remember, you cannot just write the values, I mean the ratio as it is, you need to attach any letter that is not part of the diagram. So from P to Q, Q to S, sorry, Q to S. We have the ratio PQ to QS is 2:3. So I will name this one 2X, and I will name this one 3X. My mistake. I will name this one 3X. Right. We are also given that QR to RS is 5:3. So from Q to R, R to S. Its ratio is 5:3. I now use a different letter. I will now use Y. I have 5Y, and I will have 3Y. Now we need to identify a region that has both the letters. PQ has only one letter, which is X. But from Q to S, remember QS is 3X. And then from Q to S, I have 5Y and I have 3Y. So in essence, QS is 8Y. Now we can establish the relationship. 3X is equals to 8Y. Where does this 8Y come from? It comes from QRRS. If I add the 2, it gives me 8Y. Then I divide by 3 on both sides. I have X is equals to 8/3Y. Now we have our relationship. Then we can easily answer that question. It says we need to calculate QR over PQ. Right, let's go to the sketch. What is the value of QR? Remember, this 3X is from Q to S. So QR is 5Y divided by PQ. What do we have for PQ? We have 2X, so that is 2X. Now remember, we have a relationship between X and Y. So in place of X, I'm going to substitute 8/3Y. So I will have 5Y divided by 2 into. In place of X, I substitute with 8/3Y. Then this will simplify to 5 divided by 16/3. The Y's will cancel out. Now all you have to do is to plug it in your calculator. 5 divided by 16/3. This will simplify to 15/16. Let's have a look at this one. In the following sketch, AB to BC is 3:2, and AC to CD is 10:3. Right. Let us represent those ratios on this line. We have from A to B, B to C. Remember, AB to BC is 3:2, so I can name this 3X, and I will name that one 2X. Then it says AC from A to C, and then C to D. AC to CD is 10:3, so I'll name that one 10Y, and I'll name this one 3Y. Now we need to look for a region that has both X and Y. If you look at the region AB only, it only has 3X. But if you look at it from A to C, from A to C, I will have 5X. Where does the 5 come from? AB plus BC gives me 5X. And then the same region A to C, I have 10Y. So we can establish the relationship over the region AC. So I will have 5X is equals to 10Y. Dividing by 5 on both sides gives me X is equals to 2Y. Now we have the relationship. Now that we do, we can answer the question. The question says we need to find AB is to BD. It can be written as AB over BD. Now look at What is the value of AB? In this case, it is 3x. Now I want you to take time and try to have a look at the region BD. How can we write BD? Take note, we do not have a straight value for BD. But BD is the same as saying BC plus CD. So how am I going to represent BD? I will represent it with 2x plus 3y. Why 2x plus 3y? From B to D, it's BC plus CD. Right. Now, remember, we have a relationship between x and y. It says x is 2 times y. So wherever I see x, I can substitute with 2y. Then I'll have 2 into 2y plus 3y. Take note, immediately after substituting, you must only have one variable. So in the numerator, I'll have 6y. And then in the denominator, if you plug it in, the calculator gives you 7y. The y's will cancel out. It gives me the ratio AB to BD as 6/7. Right. Now look at this one. The following sketch, KL to LN is 3:13, and KM to MN is 5:3. Let us represent those ratios on this line. We have KL to LN. So it's from L to N, that whole region. It's given as 3:13. So I can name this one 3x, and I will name this one 13x. Right. Then KM to MN. From K to M, M to N. Its ratio is given as 5:3. Now, the ratio here, I'll represent it as 5y, and I'll have this one as 3y. Now, I want to give you just a couple of seconds just to look for a region where we can have both x and y. Take note, it's quite difficult to find that region. So in this case, how do we establish the relationship? I will take the whole of Kn on top, that is 16x. Where does the 16x come from? It comes from 3x plus 13x. And I will take the whole of the bottom side of Kn, which is 8y. Where does the 8y come from? 5y plus 3y gives me 8y. Now I have a relationship. So I'll divide both sides by 8. It gives me y is equals to 2x. Now we can easily answer that question. KL over LM. What is the value of KL? KL, I have it as 3x. Now, how can we express LM? I do not have that region LM. I have a region from L to N. I want to give you just 10 seconds, 10 to 15 seconds, just to think about it. How can I express that region LM? Now, if you want the region of LM, take note that LM, if I may write it down, plus KL gives me the region KM. So if we make LM subject of the formula, I have KM minus KL. And what is KM? KM is 5y minus KL is 3x. So my region of LM will be represented by 5y minus 3x. Remember, the idea is to have one variable here. And how can we do that? By substituting that relationship. Wherever we see y, we are going to substitute with 2x. So I will have 3x divided by 5y, so I'll have 5 into 2x minus 3x. And this gives me 3x divided by, if you plug this in, 10 minus 3 gives you 7x. So the ratio KL to LM is 3/7. Now that we have mastered the skill of multiple ratios on a line, are now ready to tackle the so-called difficult questions of proportionality. Now, we have an easy approach to proportionality questions. First, you need to identify all triangles that have a line drawn parallel to a side. Very important. Then, work with one triangle at a time. Then you transfer information to the other side. Remember to use different letters. You will see what do I mean when I say transfer. Then you will establish a relationship based on multiple ratios on a line. Right. Let's go through this example. This is a typical equation. In the sketch alongside, AD to DB, the ratio AD to DB is given as 7:4. And DG to GC is given as 2:5. Determine AF is to FC. Now, remember what I said. First, you need to identify a triangle that has a line drawn parallel to a side. What I usually do, I extend those parallel sides. Sorry, let me just get rid of that. I extend those parallel sides. Then I can easily identify any triangle that has a line drawn parallel to a side. The first triangle that I see here is triangle ABF. Have a look at triangle ABF. It has a line drawn parallel to a side. Which line is it? It's the line DE. Drawn parallel to which side? To side BF. So I know in that triangle, I can apply the proportionality theorem. Right.
Boma. So you muted.
Am I audible? Okay. Parallel to which side? GF is parallel to DE. Right. Now that we have identified the two triangles, need to transfer this information. Need to transfer this information to the sketch. Now we will deal with it one triangle at a time. We have AD to DB. Its ratio is given as 7:4. So I'll have this as 7x and 4x. Let's see if we can transfer that information to the other side. Yes, we can. AD goes with AE and BD goes with EF. So you need to write it down. AD over, sorry, let me write it here. AD over BD is equals to what? AD goes with AE on the other side, so I'll have AE. And BD goes with EF on that other side, so I have EF. And what is the reason for this statement? Line drawn parallel to side of a triangle. Now let us transfer the information. AD goes with AE, and BD goes with EF. Now I need to write down the ratio. The ratio will still be 7:4, but now with different letters. So I'll write this as 7Y, 4Y. We are done with triangle ABF. Let's move on to that next ratio. It says DG, so there is DG, from D to G, G to C. Its ratio is given as 2:5. So I can name this 2W and I can name that 5W. Now let us see, in that triangle DEC, can we transfer information? Yes, I have these two sides. Once I have these two, I can easily transfer. DG goes with EF and GC goes with FC. So I need to write down the transfer. DG divided by GC is equals to, DG goes with EF and GC goes with FC. And what is the reason for that statement? Parallel to side of triangle. So if I transfer, I cannot now just write it outer side of EF because I already have 4Y. So I'll write it on the inside part, EF to FC. Now I need to give it a different letter. So I'll name this region 2P and I'll have that one as 5P. Now look at the side that has quite a lot of information. The side AC has a lot of information. And I can find a relationship where I can find a I. Then I divide by 2 on both sides. I have P is equals to 2Y. So I have a relationship. Now let us attempt to answer the question. The question says we need to determine AF is to FC. AF over FC. How can we express AF? AF from A to EF. So AF is 11Y. Where does the 11Y come from? It comes from 7Y plus 4Y. That gives me 11Y. Divided by FC. FC is given as 5P. But we do have a relationship between P and Y. So wherever I see P, I will substitute with 2Y. So I will have 11Y divided by 5 into, in place of P, I will substitute with 2Y. So that gives me 11Y divided by 10Y. The Y's cancel out, so my ratio is 11 over 10. What is important when answering such types of questions is to identify a line, is to identify a triangle that has a line drawn parallel to a side. Majority of the time, it won't just be one triangle, but it can be one triangle. In this case, we have identified two triangles. That is triangle ABF and triangle DEC. Then you need to transfer information, but with one triangle at a time. So I was given the ratio A to DB, that is 7:4, so I wrote it as 7x to 4x. Now, we transfer information. Before I write the information on the other side, I need to write a reason. So I have AD over BD. It goes with AE over EF. My reason is line drawn parallel to side of a triangle. I can proceed to transfer the information. The ratio of 7x is to 4x. So when it gets to that side, I need to just change letters. So I'll have 7y is to 4y. Then I do the same for triangle DEC. In triangle DEC, we were given DG to GC. Is to 5. I have 2W and I have 5W. Once again, I need to write down the transfer. There is the transfer. VG over GC is equals to EF over FC. Reason being, line drawn parallel to side of the triangle. But when we transfer, take note, I already have a variable on that other side, so I will write it inside. So I'll transfer it. 2W now becomes 2P, 5W now becomes 5P. Then we establish a region that has both letters, and that is region EF. So region EF, 2P is equals to 4Y. I divide by 2 on both sides. I now have a relationship P is equals to 2Y. Now we can easily answer the question. It wants AF over FC. So AF, the region A to F, I have it as 7Y plus 4Y, which gives me 11Y. And the region FC, I have it as 5P. Remember, we have a relationship between P and wherever I see P, I will substitute with 2Y. So that gives me 11Y over 10. The variables cancel out. It gives me 10. Right. My dear learners, it is now your time to answer this question. To around 10 minutes to answer this question. And then after 10 minutes, that is when we are going to do the corrections. Please attempt this question.
Later. Bila masa. No.
No.
Tolakasa.
Oh no. Oh no.
No. No. All right. Ladies and gentlemen, I hope you were able to attempt and get something out of this question. Right. In the sketch alongside, BF is parallel to CE. Right. Like I've said, for me, I prefer extending those parallel sides just so that I can see my triangles more clear. Now we need to identify any triangle that has a line drawn parallel to a side. The first triangle that I see is triangle A. I have triangle A, C, E. Take note GF parallel to CE. So that is my triangle. Which other triangle do I see? I see triangle B, F, D. Take note CE is parallel to BF. So those are the two triangles that I can work with because both have a line drawn parallel to a side. Now let us represent that information on that sketch. AF, sorry, AF to AD, AF to AD. Its ratio is given as 5:11. So I will have this as 5x, and that is 11x. Now take note, good people. From A to D is 11x, and from A to F is 5x. The difference is 6x, which is that region F to D. That is 6x. Now remember, if you look at triangle ACE, there's nothing I can transfer because even though I know this part, but I do not know that part of FE. So I cannot just transfer, say AF goes with AG and FE goes with GC. I cannot transfer because there won't be a value for GC. So that transfer will not be possible for now. Then we go to the second ratio. That ratio is written somewhat awkwardly. You have CD is 2 times BC. If you divide by BC on both sides, it gives you that ratio CD over BC is 2 over 1. That is the ratio. So from CD, D to C, C to B, sorry, the ratio is given as 2:1. So this gives me 2y, and that gives me y. Can I transfer? Yes, I can. I know those two regions. The minute I know those two regions, then I can transfer to the other side. Now, before we transfer, we need to write down the reason. Remember, BC over CD goes with what? BC goes with FE, and CD goes with DE. And what is the reason for that statement? Line drawn parallel to a side of a triangle. Now that I have written the transfer, we can now transfer information on the diagram. BC goes with FE and CD goes with ED. So BC is Y. So this time around, FE will have to take on a different variable. Let's call it W. CD is 2Y, so ED will take on a different variable, which is 2W. Then you need to look for a region that has both letters. And for me, that region is from F to D. Take note that F to D, I have 3W is equals to 6X. Where does the 3W come from? It comes from FE plus ED. W plus 2W gives me 3W. Then I divide both sides by 3. I have W is equals to 2X. Now I can easily answer that question. It is now looking for AF over ED. And what is AF? We have AF in terms of X, so that is 5X. And what is ED? We have ED in terms of W, so that is 2W. Remember, we have a relationship between X and W. Wherever we see W, we will substitute with 2X. So that gives me 5X over 4X, which is 5 over 4. Now, the second part of the question, we need to find AG over GC. AG over GC. Take note, we have nothing for AG and we have nothing for GC. That simply means there's a big chance that we are going to apply proportionality there. It comes from triangle ACE. AG goes with what on that other side? It goes with AF. Divided by GC goes with what? It goes with FE. And what is the reason for that statement? Remember, every time we use proportionality, we need to write down our reason. Lines run parallel to side of a triangle. Now, we now have AF. AF is given as 5X. And we have FE. FE is W. Remember, there's a relationship between X and W. In place of W, we are going to substitute with 2X. So it gives me the ratio as 5 over 2. Right. Can we please attempt that question for 6 marks? In the diagram, QR of triangle PQR is produced such that XS is parallel to YR. PX over XQ is 2 over 5, and PT over TR is 3 over 2. Calculate, given reasons, please be careful. This is where learners lose marks. Given reasons, the value of QR over RS. I'll give you around 10 minutes to solve this question and then finish off with the corrections before I hand over to Mr. Motlengwa for area questions.
You are muted. Unmuted. These people are thinking.
Got the answer.
Oh, damn. Yes.
Terms and conditions.
What does all of it? Eh?
USA.
Got the answer.
Inte za kweli.
Yeah. Kima batlang ke ya?
Let's go. Ama nje euka la manzi.
Hello.
Guys, are you?
Mr. Khati. Mr. Khati.
Nze onshebe na ikunhlisa na. Ke batla go tshuya ka bona na ikunhlisa. Yeah. It's a fella Gina. Ke batla go bona. It's a fella there.
Sorry,
Are you guys so?
the learners are really
Yo, shapa. Not to
Tshepo. Tshepo.
All right, ladies and gentlemen, I hope you were able to get to the answer. If not, let's work on it together.
sorry,
I'm going to
guys.
extend
Hey,
parallel signs. This helps me to
Hey.
identify all
you are
triangles.
disturbing.
Now, the first triangle that I see is triangle. Let me write it here. I see triangle PYR. This triangle has a line drawn parallel to a side. Which line is it? The line XT is drawn parallel to side YR. Then the next triangle that I see is triangle QXS. Line YR is drawn parallel to line XS. Right. Now we are given the ratios. The ratio PX to XQ is given as 2:5. Now remember, we're going to attach the
Yeah. You are disturbing.
Tshepo wa rasa.
Enda dong di la sa bua next ba.
Let's go, Mozo.
Para só ali tweets. Cuma just easy. Dia. Baba o next baba o muti da baba.
Lima vigigelo. Thank you.
I know that's what it. Down.
My mic was off, sorry. Is it fine now? Okay. I'll go back to them. The question says we need to find QR over RS. Take note, we have nothing for QR and we have nothing for RS. That simply means we need to resort to proportionality. QR and RS both appear in a triangle that has a line drawn parallel to a side. Which triangle is that? It's triangle QXS. So we will transfer QR over RS is equals to QY over YX or XY. Reason being line drawn parallel to a side. Now, we do not know the region QY, but remember QY plus XY gives me QX. And now I can easily find QY. So QY is equals to QX is 5A. And if I transpose XY, XY is 2C. So I have QY as 5A minus 2C. So I have 5A minus 2C divided by XY. XY, we have it as 2C. Remember, the idea is to have one variable there, but we do have a relationship. In place of A, we can substitute with 3 over 2C. So I'll have 5 into, in place of A, I have 3 over 2C minus 2C divided by 2C. Now this gives me 15 over 2C minus 2C divided by 2C. Now in the numerator, we will have 15 over 2 minus 2, which simplifies to 11 over 2C divided by 2C. Now plug in your calculators, the C's will cancel out. 11 over 2 divided by 2 gives you 11 over 4. So the value of QR over RS is 11/4. Right. Thank you very much, ladies and gentlemen. I'm now about to hand over to Mr. Motlengwa to start with the area questions. You may take a break for 5 minutes just to stretch your feet, and then round about 3:15, Mr. Motlengwa will start with the area questions.
Hello. I will.
Let's go movie.
Yeah. Okay.
Hola.
Yeah. Yeah. Ah. Wow. 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 Ah. Ah, it can sleep. You are. Huh?
Terraça.
Hey, look at my bingo.
Imagine, toma mela lu, toma mela lu, wena. Toma mela luna, man.
Only shopper. Active, oh my God. Hey, behave, Bunda, behave.
That's like that. Darius. Dada game. We trying to explain. Nalo.
Amelia, why?
Now you know something. Yeah.
Es kann traumatizing, sabe? Quando você vai estudar classe,
Vai viver, não tá vendo?
de não era as coisas da trabalho de rua, mas não, né?
Sabe?
Não, não quero mais que eu vou me deixar as cards. Ou era um chapéu do card. Ou para tocar uma senhora não dá esquerda de é primeiro. Ou quando eu uso para cinema. Mas eu deveria roubar também, eu quero ter as coisas.
Olha o tempo.
Aí eu não, ou de também.
Deixa eu ver.
Then you go back to the little.
Oh, dia beri kau apa dia? Iya.
Kelo na fela ni je ka batla ya loko.
Iya.
Yeah.
Seven. Oi. Tsarin gara, tsarin. Anautia kama Mugabe. Ndio fasi ndo. Tuko na pass. Tuko bila soka. Essa é o sisi kutani.
Mbona chama kubwa mno.
Kena moyo mtego.
Okay, good afternoon, ladies and gentlemen. My name is Motlengwa.
Afternoon, sir.
I will be going through the area ratio questions, like Mr. Khati has alluded initially. Can the participants please mute their mics because they are disturbing the other classes elsewhere, and also they are disturbing us this side. Can we please mute our mics and the camera? Please let us mute the mics and the cameras. Thank you very much. We are going to start with the area questions, area ratio. Our area ratio exists with two conditions, like the one that we have on our screen. Oh, thank you very much. I was muted for some time. Triangle ABP and triangle ABC, the ratio of those two triangles, they have the common height h. Height h is a common height of triangle ABP and triangle ABC. Because we said the base and the height must always be perpendicular. In triangle ABC, if we take height h as the height of that triangle, that means side BC would be the base of that triangle. From there to there, that side would be the base of that triangle. Then we check the second one. The heights would usually cancel out, and the halves would also cancel out. And then the third one also, triangle ACP over area of triangle ABC. In those two triangles again, triangle ACP and triangle ABC, the bigger triangle. Those two triangles, they have the common side. The common side of those two triangles would be side AC. If they have the common side, then there is a possibility of them having the common height. This is the first condition for us to find the area rule or to find the area ratio using we must have, for the second type, we must have the common angle. For us to have a common angle, then we use the area rule from grade 11. Area of triangle ABC is equals to A or 1/2 AB sine of angle C. 1/2 AB sine of angle C, but these two sides, remember small letters, they represent the side, the capital letters, they represent the angles. These are the two sides that are including angle C, meaning that for us to use this, we must have two sides and an included angle. But in this case, because we are doing area ratio, this angle C must be the common angle between the two triangles. For example, if we check the first example that we have here, we have a triangle here, triangle ABC and triangle APQ. Now, the first question that we have here is area of triangle APQ over area of triangle ABC. For them to be written as a ratio, one of the two must be there. One, either they would have the common side. Having common side would lead us to have the common height in those two triangles. Or two, both of those triangles are having the common angle. Now let us check the first one that we have here, whether do they have the common height or the common angle, the triangles that we are finding the ratio of. The first triangle is triangle APQ. If we check APQ and triangle ABC, ABC. Now, in those two triangles, we can all agree that angle A is the common angle in those two triangles that we have there. Having angle A as the common angle leads us to use the area rule formula. Area rule in this instance would say 1/2, and these two sides, AP and AQ, are the two sides that are including angle A that is common, that we have identified as the common angle in those two triangles. Even in the second triangle, triangle ABC. In triangle ABC, we said angle A is common Angle A appears in two triangles. Therefore, in triangle ABC, the two sides that are including angle A is side AB and side AC, meaning we are going to have 1/2 side AB multiplied by side AC sine of angle A. And then your sine of angle A and sine of angle A cancel out. 1/2 and 1/2 would cancel out. Would be then left with the product of two ratios, AP over AB multiplied by AQ over AC. Now, we use the area rule whenever we have the common angle. Those are not the two conditions that we have. We have the third condition where we have the relationship of three triangles. But we'll look into that when we are doing the examples. Condition number 3. We'll look into that when we do the examples. Now, triangles that are between two parallel lines. Mostly this one, we are going to use it with the theorem that Mr. Khati has just applied for us now. Line drawn parallel to the third side of the triangle divides the two other sides in the same proportion. Same proportion refers to same ratio. If we are saying in the same proportion, we are saying those two sides have the same ratio. So triangles between two parallel lines have the same area, but our educators will dwell much into this one when they are proving the proportionality theorem. Now, let us check the examples that we have for the area ratio. The examples that we have for the area ratio, we have the sketch here. But for us to do area ratio as well, we are going to apply proportionality that Mr. Khati has just explained for us. The statement reads as follows: in the sketch alongside, AF and DE are parallel. AD is to DC equals to 2:5, meaning we are given the ratio of AD over DC that is equals to 2/5. Because Mr. Khati has also shown us that this given ratio can be written as a fraction. AD over DC equals to 2/5. And the second ratio that is given there is BF over FC that is equals to 2/3. Like Mr. Khati has explained to us, whenever we are given the ratio, if we fill the information to the sketch that is given, we are going to attach variables to each ratio. Each ratio would have a different variable. Like this is my first ratio, meaning I will have one variable for that. This is my second ratio, then I'll have the second variable for that. Now let us check, or let us fill the information on the given diagram. The information is AD is 2 and DC would be 5. Then we are giving that information to the sketch. AD is 2, then we are going to have 2 here. Then because it is a ratio, I will attach a variable to that. That means my AD would be 2K and DC would be 5. From D to C, this side here would be 5K. And then the second ratio that is given is BF over FC equals to 2/3. That means side BF, the ratio of side BF is 2 and the ratio of side FC is 3. Now we check that BF, here is BF, BF would be 2. I've used K there, we can use X here, meaning BF is 2X, whereas FE, oh sorry, FC from here to there, FC is 3X, 3X. But our triangle has parallel lines. And theorem number 1 that Mr. Khati has just explained to us now says, a line drawn parallel to the third side of a triangle divides the other two sides in the same proportion. If we ignore, or if we look at the sketch, we have a triangle with parallel lines. We have triangle ACF. Triangle ACF has line drawn parallel to the third side, has side DE drawn parallel to side AE. F. Therefore, we can apply theorem number 1 there, a line drawn parallel to the third side of the triangle. Now, applying that will then mean I can now say FE, the ratio that is not given to me, FE over FC, kappa EC. FE over EC is FE over EC is equals to AD over DC. Line parallel to side of a triangle. And then we have the side of AD over DC. Side AD is 2K, side DC is 5K. Then we can substitute that here. Side AD is 2K, side DC is 5K. That means the K's will then cancel out. Our ratio for side FE over EC would be 2 over 5. We are then finding the third ratio from the 2 that was initially given. Now, with the third ratio means you are going to introduce the third variable because we are giving each ratio a different variable. Now, side FE, based on this, my FE over FE over EC. FE over EC is 2 over 5. That means FE here, I'm going to say FE is 2y, whereas EC would be 3y. Now we have a sketch now that is a bit complete. Now we can look at the questions, but before we even attempt the questions, Mr. Khati did multiple ratios on a line with us. There is a space or there is a line here that has multiple ratios, line BC. It has a ratio in terms of X, it has a ratio in terms of Y. Now let us find the relation between X and Y. Now we are going to say from FC is equals to 5y. Again, FC is equals to 3x. Therefore, for FC only, one can say 3x is equals to 5y. And then from there, we can find, oh, this is not 2 and 5, not 3, sorry. This is supposed to be 5, so that it can be 8y. 3x is equals to 8y. And then we can divide both sides and have our x as equals to 8 over 3y. Then we can of x. Now let us check the first question that we have. Area of triangle ABF over area of triangle ACF. Triangle ABF and triangle ACF. Whenever we are given the area as a ratio or we are given area ratios, we are going to look for the two conditions that we have for the area ratio. Condition number 1, these two triangles must have the common height, or the two triangles must have the common angle. Now let's look for any of the two in the two triangles that we are required to find the area ratio of. Now we are looking at the first one. The first one is triangle ABF. There is my triangle ABF, and triangle ACF, triangle ACF. Clearly, those two triangles will not have the common angle because they are two separated triangles, but they have, those two triangles, they have the common side, which is side AF. If they have the common side, that means they can have the common angle. If you draw a line from point A going down to this point, from point A, if you can have a line perpendicular to this, That means that would be your height for both triangles, for triangle ABF and triangle ACF. Therefore, the two triangles have the common height. If the triangles have the common height, the formula that we are using would be 1/2 base by height. In triangle ABF, a side that is perpendicular to the drawn height, a side that is perpendicular to this height in triangle ABF would be side BF. Meaning here we are going to have 1/2 BF multiplied by height all over. In triangle ACF, triangle ACF, in that triangle, the side that is perpendicular to height H would be side FC. Therefore, my formula in this instance would be 1/2, and then the base would be FC. 1/2 FC multiplied by H. Then the height, the halves, and the heights would cancel out. Would only be left with BF over FC. Then this is equals to this half and half cancel. We are left with BF over FC. Can the participants please stop muting the presenter? Thank you very much, because I'm seeing that I'm being muted now and then, but I'm aware that they will stop doing that. Thank you very much. BF over FC. Now, the BF here, we have the ratio of BF, but it is in terms of X. That means BF would be 2X over, and then we have the side of FC. But coming to FC, FC has two ratios. FC has a ratio in terms of Y, and FC has a ratio in terms of X. Because we chose the one in terms of X for BF, even for FC, we must write that ratio in terms of X. Do not make a mistake of writing multiple ratios on your area ratio. Just use one variable, like for my FC. Here is FC. For that FC, we can use ratio as 3x. If we use ratio as 3x, that means our x's would cancel out. Would be left with area of triangle ABF over triangle ACF as 2/3. That is the first one, where two triangles are having the same height. Now let's check the second triangle that we have. Triangle ACF and triangle ABC. In triangle ACF and ABC, do we have condition number 1, which is common height, or condition number 2, which is common angle? Any of the two must be there. Either they have the height or they have the common angle. Let's check the first one, triangle ACF. ACF and triangle ABC. We can see that in those two triangles, side AC is common in the two triangles. Side AC appears in triangle ACF, side AC appears in triangle ABC. That means there is a possibility that those two triangles are having the common height. Now, looking at the very same height that we have drawn, height H. Height H appears, or height H is a common height for those two triangles. Now, let us write our formula. Because we have common height, our formula would be 1/2. The base in triangle ACF is the side that is perpendicular to the height that we have identified. In triangle ACF, the base would be side FC. In triangle ACF, the base would be side FC, meaning we have height 1/2 multiplied by FC multiplied by H all over triangle ABC. In triangle ABC, the side that is perpendicular to So the identified height is side BC. Therefore, the formula for triangle ABC would be 1/2 side BC multiplied by H. And then the halves would cancel, the heights would cancel. It means we are left with FC over BC. Then we can substitute our FC. FC would be equals to 5 or 3x. FC would be 3x, whereas our BC would be the sum of this 2x and that 3x, the length BC. BC would be 5x. That gives us the area ratio of triangle AFC and ABC as 3/5. 3/5. Now, let us check the third one. Let us check number 3, where now we have area of triangle ACF and area of triangle DCE. Triangle ACF, and triangle DCE. Now, because the two triangles do not have the common side, there is no side in those two triangles, or there is no side in these two triangles that appears in both triangles. We have triangle ACF and triangle DCE. Each side has its own separate sides, but the two triangles are sharing the same angle, which is angle C. Angle C appears in those two triangles. Angle C appears in triangle ACF, and angle C appears in triangle DCE. This is the second condition for area ratio. If two triangles have the same, then we can find their area ratios. Now, for this one, because they have the same angle, if they have the same angle, our formula would be 1/2 multiplied by the product of two sides that are including the identified angle or the angle that is common in those two triangles. Now, we said angle C is common in the two triangles. Angle C in triangle ACF. In triangle ACF, angle C is being included by two sides. Angle C is formed by side AC and side FC in triangle ACF. Then we are going to have a product of those two sides. 1/2 multiplied by AC multiplied by FC multiplied by sine of that included angle, sine of angle C, all over the second triangle, which is triangle DCE. In triangle DCE, the angle C is included by side DC and side EC. These are the two sides that are including side or angle C. Therefore, our formula for area of triangle DCE would be 1/2 multiplied by the product of those two sides that are including angle C, which is side DC multiplied by side EC multiplied by sine of angle C. Now, looking at this, the sine of angle C in both numerator and denominator would cancel out. Sine C and sine C would cancel. 1/2 and 1/2 would cancel. That means we are now left with the product of those two sides. Side AC multiplied by FC divided by side DC multiplied by EC. Now let us substitute based on the given information. Side AC is given as, on this sketch, AC from A to C. If this is 2K, this is 5. If AD is 2K. DC is 5K. AC would be the sum of those two sides. That means AC would be 7K. That means we can have the length or the ratio, yeah, AC. AC would be 7K. AC would be 7K multiplied by side FC. Side FC. FC, there are two variables for FC again, either in terms of X or in terms of Y. But we can't use X in this case unless we are going to substitute the X that we have there to get to Y. But the easier way would be for us to find FC. We said 3X is equals to 8Y, meaning our FC, I can write it as 8Y. Or is it 7? Sorry, 7. Here it's supposed to be 7, not 8, sorry, 7. That means our FC would be 7. This is multiplied by 7Y all over side of DC. DC, from D to C, we have DC as 5K. Therefore, DC would be 5K multiplied by EC. EC would be 5Y. Then you can have the product of that. Those unknowns or those variables would cancel out. K would cancel out K, Y would cancel out Y. Therefore, we have our ratio as 49 over 25. We have our ratio as 49 over 25 for the ratio of triangle ACF over area of triangle DCE. Now, let us check the third condition then, the last one. And the one that I said we will talk about when we get to it. Now, we are looking for the area of triangle ABF over area of triangle DCE. Looking at the sketch, area of triangle ABF in area of triangle DCE. Two triangles do not have the common side, meaning we can't use 1 over 2 base by height. And those two triangles do not have the common angle. Therefore, we can't use half AB sine of angle C. Because those two triangles, it is the triangle here, triangle ABF, and the triangle here, triangle DCE. Now, whenever the triangles are not having the common angle or the common side, we are looking for the common triangle that is going to link those two triangles. I'll repeat that again. Whenever two triangles are not having a common side, that would lead to the common height, or they don't have the common angle. If the first two conditions are not met by the area ratio that we have, then we are going to look for the common triangle. Now, let us check the two triangles that we have. And with that common triangle, those two conditions will apply. We are going to link these two triangles using the very same conditions that we have talked about initially. Now, let's check a triangle DCE, and triangle ABF. Those two triangles do not have the common angle, do not have the common height, but they are linked to any of these two triangles. They are linked to triangle AFC, both of them. Because if we look at this first one, I will say this is triangle number 1, this is triangle number 2. Triangle ABF, I would refer to it as the first triangle. Triangle DCE, I will refer to it as the second triangle. If we look at the first triangle, triangle ABF, ABF has a common height, meaning triangle AB, find the area ratio of triangle ABC with triangle F. Again, we can look at done with, we're going to link the two from there. Then we look at the second one. Triangle DCE has a common angle with triangle ABC. Therefore, we can link the two triangles, triangle 1 and triangle 2, using triangle ABC. Or one might link the two triangles using triangle AFC, because triangle 1 has a common height with triangle AFC. Triangle 2 has a common angle with triangle AFC. Therefore, we can link the two triangles from a common triangle. Now, let us check, because whenever they have the common triangle, we are not going to just go straight to the answer. We need to solve it from those two linked triangles first. But if we solve it with AFC, with the common triangle being triangle AFC, triangle ABF over AFC, here would be my first solution from number 1. We said area of triangle AFC, area of triangle AFC over area of triangle ACF is equals to 2 over 3. That means from the common triangle, we can make area of triangle ABF subject of the formula from there. Making area of triangle ACF subject of the formula from there means I must multiply both sides by area of triangle ACF. Multiplying both sides by area of triangle ACF would lead us here. We are going to have area of triangle AFC being equals to 2 over 3 area of triangle ACF. That means for we want ABF. Yeah, that is ABF, not AFC. Ne? ABF in the numerator, it's ABF. ABF from number 1. That means wherever I see area of triangle ABF, area of triangle ABF, this is what we are going to substitute. Area of triangle ABF is equals to 2 over 3 area of triangle ACF. Again, we said we are linking the two triangles using triangle ABF. Where will I find my ABF again? I will find my ABF again from here, DCE from number 3. From number 3, ACF. Number 3 also has triangle ACF and has triangle DCE that we are looking for. From number 3, we found that area of triangle ACF over area of triangle DCE is equals to 49 over 25. That means we are going to write it here again. Area of triangle ACF over area of triangle DCE over area of triangle DCE is equals to 49 over 25. 49 over 25. From this part, from the answer of number 3, or the solution of number 3, making area of triangle DCE subject of the formula would give us area of triangle DCE, area of triangle DCE as equals to, if we cross multiply there, it would be equals to 25 over 49, 25 over 49 area of triangle ACF. Then we have found the areas, but we have found them separately. We have area of triangle ABF. We have area of triangle DCE. Now we are going to substitute them on the equation or on the area ratio that we have, because these two did not have the common height, did not have the common angle. Now we substitute. This would be equals to area of triangle ABF. Area of triangle ABF, we found it to be equals to 2/3 area of triangle ACF. ACF. All over. We found area of triangle DCE. Area of triangle DCE, we found it to be 25/49 area of ACF. 25/49 area of triangle ACF. ACF. Then that common triangle that was linking the two triangles will then cancel out, because the two triangles, we said we are linking them with triangle ACF. Then here is the chance of cancelling out that common triangle. Triangle ACF would cancel triangle ACF. Would be left with 2/3 divided by 25/49. That would give us 98/75. Now, with this first example, we have explored all three possible ways where the area ratio can be assessed. Area ratio can be assessed with these three. Either you have the common angle, the common height, or lastly, you can have the common, the common triangle. Now, we are having this last question. Can we take two minutes just to check this one?
Kalau dia dah street ni, street di Madag. Agora do dia dah ni. Qual é?
Okay, I think we took 2 minutes to check this question. Because of time, we are going to entertain this question together. Question 10 that says, if or in triangle ADF, DF is parallel to CE, CF is parallel to BE. If AB is 4 units and BC is 6 units, then calculate for 7 marks these two questions, 10.1 and 10.2. These are the exam type of questions, but our main focus, because we are doing area ratio, our main focus would be on the last question. The first one, the length of CD. You can be able to calculate that from the activities that Mr. Khati has done with us. The length of CD using proportionality theorem, if you are to find that, it would be 15 units. We are not interested in the first one for this part of the lesson, because I would assume that Mr. Khati took you through the calculation of a side whenever you are given a triangle with two parallel lines. Our main focus or our main aim would be calculating the numerical value of area of triangle FEC over area of triangle FAD. Now, here are those two triangles, triangle AF or FEC, FEC. We have the smaller triangle here, triangle AFC. I will name that triangle again, so that it can be much easier for us. I will name that triangle, triangle 1, triangle A or triangle FEC. And the second triangle we have triangle AFD. AFD, the bigger triangle in this case. Now, we must link the two triangles. Those two triangles do not have triangle FEC and triangle FAD, do not have the common height because they don't have any side that is common for both of them. And those two triangles do not have the common angle for us to use half AB sine of C. But those two triangles can be linked with one triangle. Now, it's either you can link the two triangles with triangle ACF, because those two triangles, triangle 1 and triangle ACF, have the common angle, which is angle F. And triangle ACF and triangle 2, which is the bigger triangle, will have the common height, which would be drawn from point F again. So we can link the two triangles using a triangle, because we can't use half base by height, we can't use half AB sine of C straightforward from here because they don't have the common height or common angle. Now let us check the first triangle then. Area of triangle, area of the first triangle, triangle FEC, area of triangle FEC, FEC over area of the identified triangle that can link the two, which is triangle ACF. Area of triangle FEC over area of triangle ACF. ACF. Now, the two triangles ACF and FEC, they have the common angle, which is angle F in those two triangles. But before then, I think Mr. Khati said we can transfer the information. If AB is 4 units, BC is 6 units, that means side AE, because these two sides are parallel, BE and CF are parallel. That means this side would also be 4, that side would also be 6, because a side drawn parallel to the third side of the triangle divides the sides in the same proportion. For us to have the same proportion means if this side is 4, that side would also be 4, because we are now given the actual length of the sides. If this side is 6 units, that side would also be 6 units with the lengths. Now, let us calculate the area ratio here. For triangle FEC, area of triangle FEC, angle F, as identified as the common angle, is included by side FE, meaning it would be 1 over 2 FE multiplied by FC. FC multiplied by the sine of the angle that is being common there, which is angle F. Angle F. All over in triangle ACF, ACF, in triangle ACF, that angle F is being included by side AF and side FC again. So we are having 1/2 AF multiplied by FC, sine of that common angle, which is sine of F. Now, having this then means the halves would cancel. Half and half would cancel. Sine of F and sine of F would cancel. FC and FC would cancel. We will then have area of FEC over area of ACF as FE over AF. But FE is 6 units over AF. AF would be 10 units. Simplified, it would be 3/5. Now, yes, 3/5. Now, area of triangle FEC over area of triangle ACF would be 3/5. Now that you have identified the common triangle, let's make the triangle that you are looking for subject of the formula, which is FEC. Here we have area of triangle FEC over area of triangle ACF. Making area of triangle FEC subject of the formula there would mean we'll have to multiply both sides by area of triangle ACF so that it can cancel in the denominator. Multiplying both sides by area of triangle ACF will leave us with area of triangle FEC S equals to 3/5 area of triangle ACF. Then we have found the area of one triangle, which is triangle FEC. Now we need to find the area of the second triangle, triangle AFD or FAD, but we must link FAD with the common triangle that we have identified previously or initially, which is area of triangle ACF. Now let's check triangle AFD. Area of triangle A or FAD over the area of that common triangle that you said we're linking it with, which is area of triangle ACF. Now let's check the two triangles. The first ones, they had the common angle. The first two triangles had common angle. Now let's check these two. Will they have the common angle or the common side? Triangle FAD, which is the bigger triangle, and triangle ACF. These two triangles have the common side, which is side AF. Whenever they have the common side, chances are they have the common height. And the perpendicular height in this instance would be drawn from angle F going down. There is that common height. This height in triangle ACF is perpendicular to side AC. In the bigger triangle, which is ADF, that height H, is perpendicular to the side AD. Now let us substitute then. That means in this instance, we are not using half AB sine of C, but we are using half base by height. In triangle FAD, that means it would be 1/2 base, which is AD multiplied by that perpendicular height, all over in triangle ACF. It would be 1/2 multiplied by the base, which is AC in this case. AC multiplied by height H. Then the heights and the halves, they cancel out. We are left with AD over AC. AD is from here to there, meaning AD would be the sum of 4, 6, and 15. 4 plus 6 plus 15 gives us 25. Therefore, our AD would be 25 over AC would be the distance just from A to C, which is 10. 25 over 10. Simplified way, 25 over 10 would be 5 over 2. Therefore, area of triangle FAD over area of triangle ACF is equals to 5 over 2. But you are looking for the area of triangle FAD. That means from this part, we can multiply both sides by area of triangle ACF. Multiplying both sides by area of triangle ACF would give us area of triangle FAD being equals to 5 over 2 area of triangle ACF. Now we have found the two triangles, area of triangle FEC, area of triangle FAD. We can then substitute them here because they are in terms of the same triangle. That will then be able to cancel out and give us the numerical value of the area ratio there. Area of FEC is 3 over 5 area of triangle ACF all over the second area, which is FAD, is 5 over 2 area of triangle ACF. Then the areas will then cancel out. Area of ACF would cancel out. Similar to the two conditions that we have. If you are saying the two triangles must have the common height, that common height would cancel out. If they have the common angle, that common angle would cancel out. Even if they have the common triangle, that common triangle will cancel out. Now here it leaves us with the answer as 6 over 25. Then the area here would be 6 over 25. That is the three conditions that we have for us to find the area ratio. Thank you very much for your attendance. Hopefully all of us that have participated in the lesson have signed the attendance register.